I welcome you all in the next video tutorial of pharmacognosy and phytochemistry 2. So yes students, in this video tutorial we are going to cover the industrial production, estimation, utilization of caffeine. Yes, you all are right. These are coffee beans, very rich source of caffeine, as well as yes, tea. We will talk about the tea leaves. Tea leaves are very important source of caffeine, and we know in the coke also we find caffeine. So there are different type of beverages from which we obtain different type of energy drinks are also available, right? These are very famous energy drink which contain caffeine. So yes, caffeine is a CNS stimulant. Some students write CNS depressant. Why? Please don't do this mistake. Caffeine is CNS stimulant. It is not a depressant drug. It is a stimulant drug. Okay? And yes, maybe always remember one thing, every drug is a poison depending upon the dose. If you are taking 1 cup tea or 2 cup tea a day, that is good. But if you are consuming after 1 hour or 2 hours consuming tea regularly, or these cold drinks are regularly on regular basis, then it is harmful. Okay? So let's start this drug, that is the caffeine. So let me show you the structure first, then we will start. Just me type here CAFFEINE. Caffeine structure. This is very important. Xanthine 137 trimethyl very important chemical compound, purine. Okay, so I hope you have idea about this. This is also known as trimethyl xanthine or 137 trimethyl purine. Okay, very important. C8 H10 N4 means it is alkaloid. Yes. Why it is alkaloid? Nitrogen containing compound. Okay, but it is not the true alkaloid. So I hope you remember about the true alkaloid, proto-alkaloid and pseudo-alkaloid. So I have a question for you. What is caffeine? It is true, proto or pseudo? Very important question. So let me focus upon the caffeine now. Yes, the most commonly sources of the caffeine are what? Coffee, cocoa beans also, cola nuts and tea leaves. Let me show you cola nuts also, because you must know about this plant also, because this is very important plant. This is the cola nuts, again source of caffeine. Okay, and over here cocoa also given, COCOA. Cocoa plants are very important, also source of the caffeine. So this is again very important. Yes, we know it is cultivated in India, Sri Lanka, China, Japan, everywhere tea is consumed. So this is in our syllabus. So you have to remember this one, 137 trimethyl xanthine. Very simple, 137 trimethyl xanthine. Yes, it is molecular mass 194.19. You don't have to remember this, just remember the solubility. It is slightly soluble in water, but mostly soluble in organic solvents like dichloromethane or chloroform. Very much soluble. So let us focus upon the extraction and isolation part. So first of all, yes, you have to take the sample. You will take tea leaves. Suppose in this case tea leaves are taken, and what you will do, first of all you will subject it to pulverization. You will powder it. Okay, and you will add sodium carbonate into it. Okay, first of all tea leaves are taken and you will add sodium carbonate into it. Then you will mix this, you will boil this decoction. You will prepare a decoction just like tea. You will boil it till a decoction of tea is formed. What you will do, you will take tea 50 gram dissolved in 500 ml water. You will take 500 ml water you will take, and 500 ml beaker you will take, and you will add in 250 ml of water. Actually basically this quantity may vary. Over here suppose written 250 ml. This is not sure. This is not, we cannot say this is 100% right. Yeah, you will take 250 ml. No, because in isolation we have to change the procedure as per our convenience. Suppose if you don't have sodium carbonate in your lab, what you will do? Yes, you will find for other substitutes. Suppose over here there is written dichloromethane. Suppose in your lab, if you don't have dichloromethane, then you will choose another solvent that is somewhat related to dichloromethane. Suppose chloroform. You can use chloroform also. Yes, we cannot find 100% accurate result in chloroform, but we have to change ourselves. We have to change ourselves as per our requirements. Okay. So 50 gram tea powder is taken. It is dissolved into 50 ml of water. Okay. Then you will boil it till a decoction is formed. Okay. Then what we will do? You will do filtration step. Filter the whole solution and you will add 10% sulfuric acid into it for neutralization. Again it is alkaloid. So we have to add again acid base. I hope you remember. First of all, tea leaves are subjected to sodium carbonate addition and you will boil it till a decoction is formed. You will filter the hot solution and you will add acid, that is 10% sulfuric acid. And then you will again, this neutralized filtrate is extracted with dichloromethane. So here you are using dichloromethane for the extraction of caffeine, because caffeine is soluble in dichloromethane. Not one time, you will do 2 times or 3 times as per your requirement. Okay. Then the dichloromethane extracts are combined and you will concentrate it and allow to stand, and finally it will form. But crystals of caffeine will form. This is very simple. So again a very simple procedure. Simple 2 ingredients are taken. Sodium carbonate over here and just sulfuric acid and dichloromethane. 3 ingredients. Sodium carbonate first of all you will add, then you will add an acid, then you will again use dichloromethane organic solvent to remove caffeine, to separate caffeine, to isolate caffeine. And you will do crystallization also for the purification. Suppose you will obtain crystals and they are not purified. So what will you do? You will again do the crystallization step. So I hope this is clear to you. This is method number 1. And there is another method for the extraction and isolation of caffeine. So let us read this again. The second method, in this again tea powder is taken and the extract, it was extracted with water for half an hour. Okay. Then we will filter it and we will treat with lead acetate solution. And why we are using lead acetate solution? In the previous video, we have seen that we have used lead acetate. Because just remember the test for tannins, for removal of the tannins, because tea also contains tannins. Catechins. So removal of the catechins or tannins are necessary for the isolation of caffeine. So that's why you are using the lead acid solution over here also. Then tea leaves are taken. We will precipitate the impurities using lead acetate. Then we will filter the solution. We will add sulfuric acid to remove excess of lead acetate. Okay. Then we will filter it and add charcoal to remove the coloring matter, because in tea there are different type of chlorophyll pigments are also present. Then we will again filter it and we will separate it into separating funnel and using chloroform. And we know chloroform is used for extraction of caffeine, because caffeine has high solubility in dichloromethane and chloroform. Then we will mix all the fractions of the chloroform and we will recrystallize it to obtain the pure caffeine. Again, just recall, first of all tea leaves are taken, boil in water, you will use lead acetate solution to remove the tannins. Then you will add sulfuric acid solution to remove the excess of lead acetate. Okay. Then you will filter it, add charcoal to remove coloring matter. Then you will again filter it and finally you will extract your solution with chloroform using a separating funnel at 3 to 4 times. Then you will combine all the chloroform layers and you will evaporate it to obtain the crystals of the caffeine, and you will go for the recrystallization for its purification. This is very simple. Okay. So I hope you clear all your doubts. So we have very less time. So see you in the next lecture. Lastly, I acknowledge all the sources that I have used to prepare this video. So see you in the part 2 video of caffeine.